I'm Owen.
And I'm Ren.
And
We made a robot on how robots can save people's lives from biohazards. So to find a problem to people dying each year due to biohazards or like getting like serious like health like diseases and stuff, we'll make a robot that can withstand toxic chemicals and maybe like grab samples of it if they don't know if scientists don't know what the toxic chemical is.
So the problem is hazardous work in like construction places and all that, killing or harming people. So our constraints is that it would have to filter out bad air so that the internal technology and all that wouldn't get destroyed by the spores. So we would have to have air filters or a gas mask, and it also needs to be precise so it doesn't spill chemicals. So sensors and regulating calibration, and also needs to be toxin resistant, so tungsten, iridium, and we also thought about stainless steel as well.
So then here's our how we chose stuff. So it needs to be what we would cover the outer layer so it doesn't get burnt. So it needs to be cost efficient, resistant to toxic chemicals obviously, and it needs to be durable, as in needs to be able to withstand toxic chemicals a lot more for years.
How long durability means how long it would last before it would break. Basically.
Yeah. So then tungsten and iridium and stainless steel. We chose tungsten because it's more durable and cheaper and fit our needs. And
Then iridium is. Yeah. Our point scale is 1 to 5, 5 being best and 1 being worst. So this is our scale. It's 1/12 scale. Our height of the scale, 5.8 inches. Our width of the scale is 3.6 inches, and our length is 3.4 inches. 1 inch is 12 inches. So one eye on that is a distance sensor for stuff. We'll talk about that later in the slide. And one is a camera to monitor the robot, so scientists can monitor the robot. Gas mask for filtering out the air. Wheels, it needs to have some kind of way to get around. Gyro sensor, accurate turns, and trademark for our bot.
So why the Toxobot is important is because people die each year due to biohazards, and the EPA controls cleanups of biohazards in areas, but it usually takes around a few hours or a day depending on how bad it is, and if they're unsure if it's safe to go near there, then it's it can risk health. And so the Toxobot will be more efficient at cleaning up and also taking samples in, so scientists can test if it's toxic, if they can go clean it up. Also the Toxobot can clean it up too. And the Toxobot will be fully autonomous, meaning that humans won't have to control it, because there are already robots that can clean up biohazards, but they're not fully autonomous.
So this is the cost of our Toxobot. So since we didn't want the tungsten to be super cost effective, we're only going to have a coating of tungsten, which is 1.5 inches thick, which would be about a little over $6,000. The distance sensor plus the camera, which is both eyes, is $850. The gyro sensor is a little over $1,000. Gas mask, $120. The wiring technology, for a guess, we would put $500 to $2,500. And then the tires, our guess $40 to $50. And then fabricator, our estimate would be $100 per hour for about 2 hours. So our total cost would be about a little over $8,500 to $10,500.
So then we will use a gyro sensor, which will be on the robot, not brain internal, so that the robot can have accurate turns and won't spill anything or harm it's outside of the body.
Mm-hmm. We will also use a distance sensor to detect how far it's going, so it doesn't bump into anything maybe a curb or a wall or anything like that, and spill toxic chemicals and stuff like that. Because then it would be even harder to clean up and it could damage the outside of the robot. How do I get that out of there? It would also need to detect how far the chemicals are. And that's the end, and those are our sources.
Our sources.